Please like, subscribe, and put on your notification. Thank you.
Good day, everyone. It's Mr. Benga once more, one of the mathematics facilitators of Tutelage Educational Services. And today in the mathematics class, I want to take us through the introduction of an interesting topic. And the topic is surds. What is a surd? A surd is the result of taking the square root of a non-perfect square. So when you take the square root of a non-perfect square, the result you get is a surd. So let's discuss what perfect squares are. So perfect squares, for example, let's discuss the squares of some numbers. 1. What is the square of 1? It implies 1 square, that is 1 times 1, which is equal to 1. So it implies that 1 is a perfect square. Let's look at 2. The square of 2 is 2 times 2, which is equal to 4. It implies that 4 is a perfect square. Look at the square of 3. That is 3 square, which means 3 times 3, which is equal to 9. If you look at other higher numbers, for example, 9. The square of 9, that is 9 squared, equals 9 times 9, which is equal to 81. 10. The square of 10, which implies 10 times 10, which is equal to 100. Now, all of these numbers and many others are called perfect squares. That is, if I take the square root of 100, it will give me 10. The square root of 81 is 9. The square root of 9 is 3. The square root of 4 is 2. The square root of 1 is 1. So these numbers here are called perfect squares. So when we are considering surds, we are looking at taking the square root of non-perfect square. Now, let's look at some examples, other examples of perfect square. For example, 36. The square root of 36 equals 6. Because the square of 6 is 36. The square root of 144 is equals to 12. Because 12 squared, that is 12 times 12, equals 144. Now, the examples I just listed now, the square root of 36, which is 6, the square root of 144, which is 12, have exact values. That is, they are rational. Now, let us look at, for example, the square root of 2. The square root of 2. Now, what is the square root of 2? The square root of 2 is not possible without using a calculator. Why? Because 2 is a non-perfect square. The square root of 2, before you can derive the square root of 2, you need your calculator or your calculating machine. Another example is we have the cube root of 21. This cannot be derived without a calculator, and we usually get approximated value for the square root of non-perfect square. So these roots, for example, do not have exact values. That is, their values are irrational. Now, what is a surd? A surd is an expression that cannot be expressed as a fraction or a decimal exactly. Also, it can be written as that. For example, the square root of 3. Now, let us consider the square root of, say, 1 over 4. I want you to take note that it is not only all numbers that are perfect squares. We can have decimals, we can have fractions that are perfect squares. So I want us to take that notion of our mind that it is only all numbers. For example, 100, 81, 25, 36 that are perfect squares. We also have fractions. We also have decimals that are perfect squares. For example, let's look at the square root of 1 over 4. The square root of 1 over 4. Let's look at this, can be written as the square root of 1 over the square root of 4. 1 is a perfect square. The square root of 1 is 1 over 4 is a perfect square. The square root of 4 is 2. It implies, and 1 over 2 can be written as what? 0.5. So you can see that we also have fractions or decimals that are perfect square. So 1 over 4, which can be written as 0.75, is a perfect square, because if I express the square root of 0.5 equals to 1 over 4. It is more mathematically accurate to leave the expression as a surd. So that is in the importance of surd. We are moving to the importance of surd now. It is important, or it is more mathematically accurate to leave the roots of non-perfect square in a surd form. Because if you are to use your calculator to get the square root of 3, what you are going to write out will be the estimated value. But when you write it in a surd form, you are going to get an accurate value for it. Now we have some examples of some roots of some particular numbers. So which of the following is a surd? Root 4. Is root 4 a surd? No, root 4 is not a surd, because 4 is a perfect square. Root 25. Is root 25 a surd? No, because 25 is a perfect square. Root 9. Is root 9 a surd? No, root 9 is not a surd, because 9 is a perfect square. And lastly, root 5. 5 is a surd, because 5 is not a perfect square. Now we are now moving to how to write numbers in root form that are non-perfect square as a surd. So we need to learn a particular law. You know, in every particular concept in mathematics, there are always rules guiding them. So we need to learn a particular law, or we call it a rule. And the rule is that if I have square root of AB, if I have square root of AB, it can be written as square root of A times B, which can be written as square root of A times square root of B. This is very important. This can be written as this. For example, if I have square root of 24, I can express 24 as a product of its factors. So I can have it as square root of 4 times 6. And this can be written as square root of 4 times square root of 6. So that is the rule guiding out on how to write numbers in surd form or in root form to surd forms. Now, how do I write in a particular root that is non-perfect to a surd form? It is very simple. Once you have noticed that your particular number is not a perfect square and you are taking the root, it is very easy. All you need to do is to split the number into 2. That is, split it as a product of its factors, but make sure that at least one of the factors is a perfect square. I take that again. When you are trying to write a number in root form into a surd form, you express the particular number as a product of its factors and make sure that at least one of its factors is a perfect square. Let's look at an example. For example, if I have square root of 12. Now, obviously, this is a number, this particular root is a surd. Why is it a surd? Because 12 is not a perfect square. And I said, how do we do this? We express the number as a product of its factors, that is product with multiplication, and make sure that at least one of the product is a perfect square. Now, for example, let's look at this. I can express this 12 as a product of its factors. We have, it can be 1 times 12. You know that will give us 12. But look at it. 1 is a perfect square. 12 isn't. So we have that. Another product we can have is 2 times 6. We can also have 4 times 3. So I decided to use 4 times 3. Why? Because 4 is a perfect square. But for 2 times 6, neither of the two is a perfect square. But here, at least one here is a perfect square, which is what? 4. Now, with the rule we learned earlier, we can split this to become square root of 4 times square root of 3. Now, what is the square root of 4? That's easy, because 4 is a perfect square. The square root of 4 is 2. It becomes 2 times square root of 3. Then our answer will be 2 root 3. That is, square root of 12 in surd form is equals to 2 root 3. Square root of 12 in surd form is equals to 2 root 3. Now, based on this example, let's have a go at some surds on how to write them, to write some roots of non-perfect square as surds. For example, the first one here we have root 45. Remember the rule. You express once you have noticed that the number is a non-perfect square. Express the number as a product of its factors, but make sure that at least one of the factor is a perfect square. If neither of the factors is a perfect square, that you are not doing the right thing. When you are expressing the non-perfect square as a product of its factors, at least one of the factors must be a perfect square. Now let's express 49 as a product of its factors. For example, I can have 3 times 15. 3 times 15 equals 45, but I cannot use that. Why? Because neither 3 nor 15 is a perfect square. Now let's move on to, say, 5. 5 times 9. Obviously, 5 times 9, or you can call it 9 times 5. You notice that 9 is a perfect square. So we can express 45 as 9 times 5. So we have square root of 9 times 5. And based on the rule we learned earlier, we can split this to become square root of 9 times square root of 5. You notice that this is a perfect square. The square root of 9 is 3 times the square root of 5. 5 is not a perfect square, so we still leave it as square root of 5. So we have it as 3 root 5. So the square root of 45 equals 3 root 5. The square root of 45 equals 3 root 5. Another example, let's look at the square root of 32. Let's look at the square root of 32. Obviously, this is the square root of a non-perfect square, because 32 is not a perfect square. Now, let's express 32 as a product of its factors. And we also put into consideration that one of the factor is a perfect square. Now we can have a lot. We can have 4 times 8. We can have 16 times 2, because you notice that 4 times 8, 4 is a perfect square. We can have 16 times 2. 16 is a perfect square. So let's express 32 as square root of 16 times 2. This can become square root of 16 times square root of 2. The square root of 16, since 16 is a perfect square, is 4 times the square root of 2. So this becomes 4 root 2. So the square root of 32 equals 4 root 2. To the last example we are going to be looking at. So based on what we have done today in surds, this is just the introduction of how to write the root of non-perfect squares as a surd. So for example, if I have the root of 8, 8 is not a perfect square, so it can be written in surd form. I express 8 as a product of its factors and make sure that one of the factor is a perfect square. So 4 root 4 times root 2. So square root of 8 is 2 root 2. This is just the introduction of surds. With the knowledge of how to write the root of non-perfect squares into a surd form, we can go further from now to look at the operations with surds. that is how to add, how to subtract, multiply, divide, and rationalize surds. So it is very important that we know how to write the root of non-perfect square in surd form. Because if we cannot write the root of non-perfect square in surd forms, then we cannot proceed to how to add surds, how to subtract, how to multiply, divide, and rationalize. So this is just the introduction. Then subsequently, we will look at the operations on surd. Till next time we meet in our surd class. Goodbye for now.